Three overweight people, Ari, Barry, and Chris, commence a diet. The chance that each person sticks to the diet are 0.6, 0.8, and 0.7, respectively, independent of each other. What is the probability that all three people stick to their diet? Because they don't give us any probability, we'll have to start with a statement. And my statement needs to be something like, let A be the probability that Ari sticks to his diet, B that of Barry, and C that of Chris. So you start off with the sum statement to know what your science means. Okay, I'm going to write this down. The probability that Ari sticks to his is 0.6. Probability for Barry is 0.8. And the probability of C of Chris is 0.7. The first question, it says that what's the probability that all three people stick to the diet? So that is the probability that I have A and B and C. Now that is the same as the probability of A and the probability of B and the probability of C. That will give us 0.6 times and is times 0.8 and 0.7. And that gives us a total of 0.336. In other words, makes sense out of that, 33.6% chance of doing that. The second question is only, so that's A. B, what's the probability that only Chris sticks to the diet? Now, if Chris sticks to the diet, it means that Ari is not, and Barry is not, and C is. Okay, so we don't have that at this stage, so I just can find that because that is pretty simple. This needs to be 0.4. The probability of Barry not is 0.2, and the probability of Chris not sticking to is 0.3. So that will be the probability of not Ari times the probability of not Barry times the probability of Chris. That will give us not Ari is 0.4 times 0.2, and definitely Chris is 0.7. So just for this question, we have that one, not that one, and that one. That's where the values come from. For C, now I'm going to take C a little bit longer to explain because this is this comes up quite often. They say at least one of the three people stick to their diets. Now, I think the easiest to explain that is by means of a tree diagram. If the first person, which is Ari, if Ari can either stick or not stick to his diet, right? So Ari can stick or not stick. Then we look at Barry, and Barry can either stick or not stick or stick. That was stupid. So Barry can stick or not stick, or Barry can stick or not stick. Right, the third person is either C or not C, C or not C, C or not C, C or not C. Okay, so in this case, A, B, and C sticks to the diet, and in this case, none of them stick to their diet. When I say at least one of the three people stick to their diet, and the other thing I wanted to say was, remember that we said that this is a complement, they complement. Altogether, they need to add up to 1. So all of this need to add up to 1 as well. So if I have a look, this is because it's my sample space. If they say at least one of the 3 people stick to the diet, it means that here one of them stuck to the diet. In this one, I'm not going to write all of them, but in this case, A, B, not C. Okay, let's do it. A, not B, not C. A, not B, not C. Not A, B, C. Not A, B, not C. Not A, not B, but C. And so there's the 8 possible outcomes. If they say at least one of the 3 people stick to the outcomes, which means at least 1, there's at least 1 here. Oh, wrong pen. There's at least 1 here. There's at least 1 here. There's at least 1 here. At least 1 here. At least 1 there. At least 1 there. At least 1 there. So all of them, there's at least 1. So it's all of those, which means I have to go this times this times this, plus this times this times this, plus this. So that's the long cut. Okay, there's a shortcut though. To find this, it's everything except the others. So if I say the probability that at least one of them do, so at least one, means that we are looking at the complementary event of not any of them. So it means 1 take away the probability of not A and not B and not C. Because that's the only one that's not part of the whole process. That does not include any one of them. And that will be 1 minus the probability of A times probability of not A times the probability of not B times the probability of not C. Okay, 1 minus probability of not A is 0.4, multiply by 0.2, multiply by 0.3. That gives us 1 minus, 1 take away 0.024, and that gives us 0.976, which gives you a 97.6% chance that at least one of them will stick to their diet.